There's an alarming trend out there among ceramic body armor manufacturers that utilize very thin plates and very thin polyethylene backers. Not only do these plates lack proper drop protection, most of them aren't even drop tested at all. But the alarming thing is that the polyethylene backer is so thin that will barely pass NIJ ballistics tests. That reduction in redundancy should concern you, and I'll tell you why right now. We often talk about how great ceramic armor is at stopping high-powered ballistic threats. What we don't always talk about is how that ceramic is vulnerable when the ceramic is damaged. So if you get one shot into the plate, that ceramic is vulnerable to additional shots. So the one vulnerable issue with ceramic armor in general is that once that ceramic is gone, it will allow other shots through the plate and makes the plate vulnerable to additional rounds. Those rounds can be of the same caliber, or they can be of a less powerful caliber, less powerful projectile. Ceramic armor becomes very vulnerable after the first shot because the ceramic is gone in that area. And it's damaged in an area greater than you can see, because when you peel the ceramic back away from the wear face and look on this side of it, you can see a large area of spalled off ceramic. Let me show you what I mean. Okay, so this is a ceramic armor plate. This is our model 8002. It's a silicon carbide ceramic tile array with lots of little pieces in here. This is done for multi-hit performance. The ceramic armor plate is built like this most of the time. The threat's coming in from this way. It hits the ceramic breaks up, tumbles, stops the projectile. The backing plate is behind it against your body like this. Is normally made for us out of polyethylene. That catches the projectile and the fragments, the jacket and all that stuff, captures the energy, and it decelerates it relatively quickly back here, but results in a bulge in the polyethylene as that deceleration occurs. So once these tile are damaged, or once the tile is damaged out in the front of the plate, the strike face of the plate, then you don't have really anything up here to knock down those high power threats. And that results in a vulnerability. So this is a ceramic strike face. It has a crack arrestor on it, but this is kind of the front of the plate like this. You would normally have your polyethylene back here, and it would sit like this. Okay, so I've taken this off, and I had peeled the ceramic away from the polyethylene backer, and I'm showing you the back side of the strike face. And you can see with this black marker, I've outlined the area of cracking and spalling and thinning of the strike face within this circle. So this is about 3.5 inches or 4 inches across. Any other projectile that goes through this area here will be encountering less material than it did originally. So that means less resistance. That means a reduced stopping power. So when you shoot ceramic, especially a monolithic, one piece of tile, you have this spall circle in the back. And that means that you're vulnerable to additional rounds. That is the primary weakness of a ceramic armor plate. Especially a level 4 plate, you're really good for one hit. Because if another round landed in here anywhere, it would go right through. It would go right through the plate. I think what we all want to understand is whether or not this can be fixed or improved. Can the resistance of a ceramic armor plate be improved based on the vulnerability encountered after shot 1? And that is what we're here to talk about today. Okay, so the answer to the question is yes, it can be improved. And here, there are really two ways to do it. And the first way is to use a ceramic tile array design that limits the amount of spall in the back of the plate, or in between the ceramic and the polyethylene backer. If you are damaging less tile, then your resistance in surrounding areas is greater. So it's kind of a basic thing. You have more tile left. You can do that with a ceramic tile array. You can tell it works because this is I'm showing you a ceramic armor plate that stopped M993 and Swiss PAP down here. Very high power rounds. This plate stopped 30 caliber M2AP. This is a ceramic tile array. You can tell all the little pieces are put together to make this pattern. You can see them in there. And this is a single tile, a monolithic. Now I'm going to show you this difference. Look at the difference in the tile damage between the ceramic and the polyethylene. This area down here on a monolithic is much, much larger than the kind of controlled damage you get out of a ceramic tile array. But, so that's visual proof right there that you have more undisturbed ceramic when you use a ceramic tile array versus a single piece of monolithic tile. Almost everybody uses the monolithic, all the big names, and that's fine. It works, especially for one shot. It does work, and a monolithic plate will work when it's built properly with proper crack arresting layers. But the science of it, okay, the physics of it say that this will occur just because of the nature of its construction. It's just the nature of it's one piece of tile, so this is going to happen. But it is occurring in the ceramic itself, otherwise the tile wouldn't work properly like it's supposed to work. You get a lot of predictability out of the monolithic, and I'm not putting it down, I'm just saying there are ways to improve your chances in a multiple hit scenario. We're talking about strictly about multiple hits, not one hit. Because I think we can all agree that ceramic armor is pretty good at one hit, at resisting one hit. I'm talking about ways where we can increase the ballistic resistance over multiple hits, right? The first way, use a ceramic tile array, because the ceramic tile array results in less ballistic damage, less tile damage after the first shot. And subsequent, as you can see, this shot of Swiss PAP actually resulted in pretty controlled damage as well. You've got a lot of the plate still left with this silicon carbide ceramic tile array. This is the tile, this is the actual strike face off of our model 8002s, intended for heavy duty use to stop tungsten ballistic threats. So the second way is to use a thicker backer. Okay, so we know that polyethylene is resistant ballistically. The problem with using 100% polyethylene for an extremely high power threat like level 4 RF3 threats, 30 caliber M2AP, is that it'll go right through this amount of material. Which I'm going to exaggerate here a little bit and show you a backing plate that is thinner than normal, and then I'm going to show you the other one, because this shows you that the backing plate thickness can be adjusted. So we can have either a thin back plate that will resist ballistically very little, or we can increase the amount of PE in the wear face like this to a thicker backer that has more ballistic resistance. Now, you get to a certain point at which the thickness of the backer becomes viable in and of itself. This backer on our model 8002 can withstand some lead ball 5.56 and 2.23 on its own. So even after, even after the ceramic is gone, that backing plate can resist lower powered calibers, lower powered projectiles. So you don't know you don't know what kind of threat you're going to encounter. If you're wearing a level 4 plate, it doesn't mean that you're going to only encounter the level 4 threat. You're going to encounter what's out there, right? You're going to encounter AR-15 lead ball stuff. You're going to encounter M855. Everybody's got a lot of that usually. You're going to encounter lots of stuff. You know, maybe a hunting round, a 308, or you're going to, if you're really unlucky, you're going to have somebody that's bought a World War II cartridge of 30 caliber M2 AP. Not likely. You could have somebody that uses tungsten against you. That's a bad day. But the fact is, the most common rounds that are out there are those AR-15 lead ball ammo rounds. I think, if you guys feel differently, leave me some comments. But the 5.56 and the 2.23 stuff, lead ball stuff, is the cheapest, so there's going to be a ton of it. If you get hit with some of those lower threats with a design utilizing a thicker backer, then you're increasing your chances of survival once the ceramic is gone. That thicker backing plate can offer, at sufficient thickness and quality, can offer enough resistance to stop some of the more common 5.56 and 2.23 rounds, and that gives you a higher probability of survival in any scenario like that. Point to recap, there are two ways to compensate for ceramic armor's vulnerability after the first shot. The first way is through the use of a ceramic tile array. And the second way is to increase the thickness of the backer used in ceramic armor plate manufacturing. And the way that we do both of those is by offering you models that use the ceramic tile array and that use a thicker backer. And they are called our Firefight Armor line of products. Firefight Armor gives you the highest probability of success because it uses that thicker backer in the back. I mean, not all of them use the ceramic tile array. We do use some monolithic multi-curve on some of them. So we do go in and we add a thicker backer to the Firefight line of armor that we offer. It's on our website under the main navigational menu, and that gives you a better chance, because many times I have shot a level 4 plate and then come alongside of it a couple of inches away with something different, something lower, like a M855. And whatever you want to say there, it fits the bill, because it's thinner ceramic there. There's either no ceramic there or thinner ceramic there. If you're going to stop that round, you really have to rely on the backer more.